Assalamu alaikum and very good morning to all. Dengar. Okay. Honorable Vice Chancellor, Professor Dato T.S. Dr. Isri bin Zainuddin, University Malaysia Pahang Sultan Abdullah, Honorable Deputy Vice Chancellor, Professor IR Dr. T.S. Amos Zias Sulaiman, International and Academic Affairs, Professor Dr. Mahazir bin Ishaq, Dekan, Faculty of Mechanical Automotive Engineering Technology, University Malaysia Pahang, Al Sultan Abdullah. Honorable guest, distinguished colleagues, faculties, and students. I am deeply honored and humbled to be standing in front of you today to deliver Syarahan Umum Professor entitled Sustainable Machining in Context of Industry 5.0, leading to eco-friendly manufacturing for a greener future. I am also delighted to see such a diverse audience in here, from industry, from school, college communication, technical from Temallo, college technical Temallo, and different faculties, different level of faculties. All right, so today, next slide. I continue the next slide. Okay, I consider the 10 items today to discuss in here. Number one, because this is the global problem, carbon emission. This is because the carbon emission contribute to the global warming and also the greenhouse effect. So this is the number one, how to control this carbon emission from the industry. And what is the current scenario in the industry using the conventional machining? This is the second topic. Third topic, I consider how to become a sustainable machining using industry, using the existing facilities, and then consider roadmap to sustainable machining. And then we consider alternative solution. What is the alternative solution to using the conventional fluid to the alternative fluid? And we also try to develop the integrated system which is using the MQL, minimum quantity lubrication. This is the system which is support to the sustainable machining. And then we develop the sustainable machining goal to become a greener future. And also I show the some of the assessment result based on our research, and what is the barrier to marketplace for alternative fuel or the lubricant. And finally, you can see the future sustainable machining. So this is the 10 point I try to discuss today. And next. All right, we can see in here carbon emission distributed from the different industry. Energy industry, they contribute the 1/4 of the carbon emission, and manufacturing industry also that is part of the energy industry, but we can separate because today I talk about the manufacturing industry. This is also contribute to 1/5 of the carbon emission from the manufacturing industry. And transport industry 14%, agriculture, forest is 24%, building 6%, and other industry is 10%. So, what is the problem for the carbon emission? To increase the greenhouse effect due to the carbon emission. In here you can see the greenhouse effect normally mainly contribute to carbon emission. This carbon emission comes from manufacturing industry, 1/5%. So how to control this carbon emission in manufacturing industry? They have the 3 problem in here. Number 1, when the greenhouse effect, the earth temperature goes rise. This is number 1. If the earth temperature goes increase, so they have the different causes. Number 1, for example, rainfall pattern is globally changed, rainfall. So sometimes without season they have the heavy rain, and sometimes the flash flooding. Another one, we can see the earth temperature rise. So sometimes in the forest they have the oil firing. And ocean, they absorb the excessive heat and carbon dioxide, and this leading to the sea temperature rise, and this threatening to the marine system in the sea. So that's why sometimes you can see the fish die in the sea due to the acidity. They develop the acidity in the sea water. And also we have the weather event. Sometimes we can see the highly possibility to the heat wave. Sometimes the hurricane or the storm due to this global warming and climate change. So how we can say this problem, how to address this problem? First of all, we reduce carbon emission, number 1. Number 2, transition to the renewable energy sources. Third, we can see the sustainable practice in all activities. That's why today I'm talking about the sustainable machining, because this is our main target to minimizing the carbon emission. Because emphasize the national strategy for manufacturing industry, especially for sustainable development goal and the industry 4.0, and also enforcing the the carbon emission standard, for example, ISO 14064, and also the greenhouse gas protocol. So we have to minimize our carbon emission in the industry. So this should be, this is bound to, because we also follow the standard and policy, existing standard and policy in the manufacturing industry. So how we can reduce our carbon emission? Using the sustainable machining. They have the 4 elements. We can say the 4E. E means reduce the energy, number 1. This is our main target. Our system, we have to how to minimize or we can reduce the energy consumption, number 1. Number 2, economical impact or the eco-friendly. So minimize environmental friendly impact, number 2. Number 3, we can see the economical viable. Number 4, we can consider the system should be the efficient and effective. So the 5S, we can consider the 5S. This is my talking point today, so I can talking about for this 5S. And, 5E and 2S. What is the 2S? One is the society. So when you control this 5S, they have the society responsibility. So what is the benefit for the society? Number 1. Number 2 is the sustainability. So 5E with the 2S. So becomes a greener future. Okay, next. All right. Sustainable machining, when talking about the sustainable machining, we have the 4 component, the pillar of the sustainable machining. In terms of the technological aspect, so product should be the high quality. When the industry, product should be the high quality. This is number 1. And number 2 is the economically viable. That means economically profitable. The cost should be the cost effective, the less price to produce the product. Third is, this is the main component today talking is the how to energy efficient or the environmental impact. So because when we're talking about the Industry 5.0, one of the pillar is sustainability. So if the sustainability, we have to consider the minimum energy consumption using the eco-friendly machining system. And third one, this is actually the not considered the Industry 4.0, is the society responsibility or the society, the human less risk or the less hazard. So these 4 components. Now next slide, we can go to the product quality. What component we need to consider during sustainable machining? Next slide. All right. So these things we need to consider when talking about the product quality. Product surface should be the very smooth. That means the surface finish, good surface finish. So how come we can define the surface finish? Number 1, tool life should be the higher. When using the machining system, they have the tools. So this tool life should be the extended tool life. And for productivity, we can consider high material removal rate. So these 3 components we can consider in here. And so the product, we can see in the cutting temperature, cutting force, and the cutting power. So this should be the minimum, so reduce the energy consumption. So when consider the sustainable machining, so this is the product quality related component we need to manipulate or we need to control this parameter. Next slide. Next, okay. Cost effectiveness. When you're talking about the cost, so we can consider we have to find the alternative tools, because tools is one of the components. So the tool cost we need to minimize, and lubricant and coolant cost. This is the main component of the product cost. So coolant cost, cutting tools, and electricity is the energy. So how we can the energy efficient system to using our industry. This is and material cost. And the other cost is the we can call disposal management. Disposal, either storage or management or the maintenance. So these things we need to consider. Next slide. This is the environment. The environment, they have the polluted either air, water, or the this is called the soil. So how to minimize this contamination? So because we're using the cutting fluid, so they have the lot of the harmful element in the cutting fluid, so how to reduce this contamination in the environment, and also energy consumption and eco-friendly. Next. Society. This is one of the components we need to consider in the Industry 5.0, social responsibility, or reduce the hazardous or the risk in the hazardous risk in here. So we need to consider the operational safety, operator safety, process safety, and also the health. Personal health means the worker health. So these things we need to consider in the sustainable machining. Okay, next. Okay, so this is actually what is the currently available method or the process we use in the industry. Conventional machining, either CNC machining, we can using the turning, milling, grinding, drilling, facing. So this type of the process we currently using. And what is the current cutting fluid? Because cutting fluid is one of the main component in here. So when you select the cutting fluid, what is the main component you can consider to select the cutting fluid? Because the currently using the all cutting fluid, all is there, they have the positive and the negative aspect. What is the positive aspect? When you consider the cutting fluid, we need to consider the 4 elements. Number 1, this should be the more lubricant. So when you consider cutting fluid, is more lubricant. What is the lubrication? This is contribute to the less friction, less wear. So this is the 2 things. And the heat reduction also reduce. Number 2 is coolant. When you using this cutting fluid, there should be the temperature should be reduced. So this is the second item. Third item is the ship transport. So take from the cutting zone. So this is the third item. And fourth item we can consider is the rust prevent or the corrosion resistance. So these 4 components you consider. But currently we can using the water as a coolant. Water is the good conductor, but they have the less lubrication properties. So this is not ideal for, and they have the corrosion, you can call that they can cause the corrosion. So this is not ideal for the current sustainable machining. Second one, normally using the mineral oil. Mineral oil, lubricant is good, heat transport also good. However, the problem is this is non-toxic. This is also corrosive. Sometimes they have the corroded because they have some additives in the mineral oil. So that is not suitable for the sustainable machining. And then come out the emulsion. Emulsion, we can come the water in oil or the oil in water. So they have the 2 things. And they have the synthetic and semi-synthetic. All they have the positive and negative property. Next slide. We can see the sum of the video in here is the practical life. Next. Next slide. All right. So when you select the cutting fluid, first we want to see what type of the method it is, either milling or the turning or the what type of this is number 1 type of the machining is, because the different process, different cutting fluid we need to select. Second is what type of the material you want to cut, soft material or the hard material. So it depends on the lot of the, I can see the taken, okay, next slide. So this is the normally use water, either mineral oil, synthetic or semi-synthetic, or the water soluble cutting fluid. So they have some problem in the environment and the human health. So what is the environmental adverse effect? Next slide. adverse effect in here, this is, next slide. Okay, so why we want to change our mind to conventional machining to the sustainable machining? Number one, in here you can see coolant cost is the 17% of the total cost of the product. So this is very high. So that's why we want to find the alternative solution to reduce the coolant cost and the other energy consumption. Okay, next slide. Okay, you can see in here, conventional coolant, I already mentioned, they have the 4 advantages in here. This is the good lubricant, good seep removal capability, also the corrosion resistance, and so the heat dissipation. So these 4 criteria is good for the conventional machining. What is the adverse condition? Next slide. Adverse condition, this is contribute to the Industry 5.0, because Industry 5.0, this should be environmental safe and also the reduce the human health risk. You can see in here environmental impact. So they have the water pollution when using the conventional fluid. That lot of the fluid is passing through the industry, then goes to the river, and the river is polluted. Sometimes the soil is also polluted. When in machining, they have the mist or the vaporization. This is also the environment or the air also polluted. So this is the, and also you can see the floor is very messy. Is the slippery condition. Sometimes water is happening accident. So that's why you need to replace this conventional machining, conventional fluid to the sustainable cutting fluid. Next slide. So you can see the human. This is the main cause in the Industry 5.0. Why conventional fluid convert to the sustainable machining fluid. So because when in machining they have the mist or vapor, this we can take from the mouth or the nose, and they have happening a lot of the problem is occur. So that's why our carbon emission standards, so we need to minimize this contamination or risk. Next slide. All right. So conventional fluid convert to the more sustainable fluid. That means I already mentioned either synthetic or semi-synthetic or the emulsified oil. So they have the all 4 component. Then, and also we can improve the microbial resistance. And next slide. Next. All right. So come out this is the final choice for the conventional fluid to the sustainable fluid. This is a biodegradable oil or the vegetable oil using as a cutting fluid. So this is a lot of the, this is biodegradable, less toxic, and also the low carbon footprint. That means this is called the eco-friendly. However, they have the problem. This one also they have the problem. That means the low thermal conductivity. This is the one of the main component for the cutting fluid. Next slide. Next. All right. We can see in here, this is the history why it becomes a sustainable machining. First, from the very beginning, Industry 1.0, they start from water and mineral oil as a cutting fluid. Then comes is the synthetic, semi-synthetics, and finally goes to the biodegradable, or we can say the vegetable oil as a cutting fluid. And then how can reduce this adverse situation to the, so we can come out the new cutting technology. That means we can call the dry machining. Next slide. Okay, we can see in here, dry machining. So if the dry machining, they are not using the cutting fluid. So 17% of the cost we can cut in here. So number one is the dry cutting, but they have the lot of the advantage. Number one advantage, no cutting fluid, no recycling system for the disposal. So you can cut the disposal system, number one. Number three, this is the environmental friendly. So this working place is neat and clean. However, they have the problem. Number one problem is the cheap disposal. Cheap is surrounding the working place. This is the number one. Number two, because when you dry machining, they create the high heat and also the high friction. Sometimes you can see this is the firing. We can see during the fire. Dry machining, they have the fire. So this is, and also reduce the productivity, reduce the product quality. So that means this is, although this is we can call sustainable process, but this is not good for the whole material. So this is not the final solution. Then we can come out the cryogenic machining. But the cryogenic machining, one of the main drawback is the initial cost is very high. Product quality is good. Temperature also controlled. So this is another, but main problem is very high initial cost. So then we can come out the MQL system. So minimum quantity lubrication. This is our final solution, becomes a sustainable machining. Next. All right, that's how you can see in here, chronological development of the sustainable machining. First start from dry machining, then cryogenic machining, and then come out the minimum quantity. But minimum quantity we can using the conventional full lubricant, that means the biodegradable coolant, and also we can using the nano coolant. Nano coolant, this is the new advancement of the coolant. So we can using so this is the alternative solution. And the future research, this is called the lubricant hybrid system. They have the lubrication, also the coolant hybrid system, and also you can consider the pico hybrid nano fluid. Next. All right, so what is the roadmap to become a sustainable machining? First, we need to consider the machining technology, then the cooling system, what type of cooling system we can consider, alternative coolant, and waste management system. And finally, you can see the integrated system. So I try to, today maybe more concentrate the coolant technology and the alternative coolant becomes a sustainable machining. Next. All right, so this is the sustainable machining coolant system. We already mentioned. They have the lot of the choice. Whose choice I can pick based on your available facilities. For example, if you're using the cryogenic, so we have the initial cost is very high. So, but when you consider the minimum quantity lubrication, this is the small investment. Initial cost is very less, and this is good for the quality is also good. This is, you can see in here, MKL, nanofluid MKL, hybrid nanofluid MKL, hybrid nanocoolant MKL, and so other type in here. So we only consider in here 3 types. MKL with the nano coolant. Next. All right, so this is our integrated system. We can see in here our main intention, energy consumption less lead time. If the lead time is less, so production cost is less. So that's why you can come out our system is a MKL system with the 3 different containers. So you can using the 3 different type of the coolant for the different machine at the same times. So, and they have the 6 nozzle, and you can control, you can see the bottom of the thing, they have the monitoring. So they have the 6 nozzle. We can control the flow rate. We can control speed. All this control individually, the 6 nozzle. So we can consider the 3 machine in here at the same time. So you can reduce, ideal time is reduced, downtime is reduced, and also we can, this is the IoT control system. So next. Okay, they have the another, this is for the future research. We can combination of the cooling and lubrication system. If you permitted, this is some of the alternative solution you can consider in here, either internal cooling or the external cooling with the combination of the 2 different method, either the cryogenic MQL or the MQL with the other coolant. For example, liquid carbon dioxide or liquid hydrogen, liquid nitrogen, so you can using the different technique in here. Next. All right, no, previous slide. Okay, this is the sum of the result using the different method. We can see the green, this is our nano coolant MQL result. So this is mass, we can see right hand side. So this reduce the tool wear is reduced is very much. So that means if tool wear reduced, that means the tool life is very high. So this is the one of the advantage to using the nano coolant in here. Next slide. This is the tri-hybrid nanofluid. All 3 surface roughness is reduced. That means the good surface roughness, tool wear, and okay, both are the tool wear. Flank wear means the tool wear. So this is also encouraging result in here. Next. All right, so this is the very good outcome in here. Industry, this is the tool wear. We can see they have the 3 zone. Mainly the 2 zone in here. One is the less wear and the safe zone. So based on the requirement for the industry people, so they can select in here. So same color is the same tool wear. So we can manipulate our speed and the feed rate, our targeted productivity. So we can increase the productivity based on this outcome. Next slide. We can see in here, I can compare the 3 different methods, MQL with the flooded. The now conventional method is flooded. Next one is the MQL with conventional, means we can using the conventional fluid. That means we can consider the biodegradable oil. And last one is considered the eco-friendly nano coolant. So this is our alternative coolant in here. So you can see the surface finish is very nice compared to the other 2 methods in here. Next. All right. So how can we come out the alternative coolant using our nano fluid or the nano particle? So they have the in here, you can consider the first, we can select the nanoparticle, either the mono or the hybrid or the tri-hybrid. So it based on the different combination, either metal or the metal oxide, ceramic carbide, or the ceramic. We can, next slide. All right. This is the sum of, previous slide. Okay, again, this is the sum of the example in here. Either we can combination of the different material in here, either the metal or the metal oxide, metal carbide, or the metal nitride. So this is a combination based on your requirement. Next slide. All right. So then we can using the base fluid. Base fluid we using in here water and the ethylene glycol, but they have the other option. They have the other option in here. Next slide. You can see what is the other option. We can using the mineral oil or next. All right. So this is the sum of the example of the different base fluid. synthetic ester or the semi-synthetic oil or even the mineral oil, biodegradable oil as a base fluid. But we are using the water and ethylene glycol in our example. Okay, next, no previous. All right, next slide. All right, in here, after mixing all these things, now we can check whether this one is stability of the fluid in here. So, stability, they have the different method to enhance your stability. So, either mechanical or chemical. You can see first is we can using surfactant in here. So, different type of the surfactant we can use in here, but we are using the CTAP, SDS and SDBS and PBD. But they have the other combination, either the negative charge or the positive charge or the both charge. It depends on your requirement. Next slide, you can see this is some of the example in here. So when you do the, this is a different method. We can improve your the stability of the nanofluid in here. Next slide. Next. All right. So this is the how can check your stability. So this is the sum of the method. Which method is available? So this depends on your available method. The potential, US viscous, and the other type. Normally, they using the one or two method to check your stability. Next slide. All right. So how to improve, next slide. This is the chemical method to improve the stability. So either you can surfactant addition, what we using our method, we can using the surfactant, or we can control the pH, or you can the surface modification and so on. So our technique we using the surfactant addition. Okay, next slide. Next. All right, so this is the actually parameter depends on the nanofluid or the alternative coolant. Depends on the lot of the parameter in here. When using the ultrasonication, so they depends on the power, depends on the speed, frequency, and the so on. So lot of the parameter is there, and also the depends on the base fluid property method, how to prepare. So lot of the parameter depends on in here. So next slide. So how to check your thermophysical property, either thermal conductivity, viscosity, specific heat capacity. It depends on different methods. So I can show you in here, because this is the more complicated interaction between the different parameters. So you can, for example, in here, NN method I can using. So the lot of the parameter we can manipulate in here. Finally, can come out our expected, because the nanofluid we need to the high thermal conductivity and the less viscosity. So this is the two multi-objectives targets. So we need to using the multi-objectives optimization to come out our final or the targeted nanofluid. All right, next, the nanocoolant. This is the sum of the method you can using in here. Either combination of predicted model and the optimization model. So ANN with the genetic algorithm and the fuzzy or the genetic algorithm. So this is the depends on your capability. Next slide. All right. So now, how to develop our sustainability model? This model we can using our final come out our model in here. So some parameter we need to reduce, some parameter this we can the maximize our parameter. For example, in here, machining cost we need to should be the reduce, and energy consumption the less energy consumption, carbon emission also less, waste also the less waste, and coolant or the lubricant should be the less consumption, and health risk also the less, contamination less, and also what is the high in here? Product quality should be the high, material removal rate should be the high, and geometric accuracy should be the very high. All right, tool life also high. So this model we are using our sustainability model in our system, in our final result. Next slide. All right. So this is our experimental flow in here. We are using the soft material in here. It's called the aluminum alloy, because when you machining aluminum alloy, the build-up base is very high. So we can how to reduce this. So cutting inside using the uncoated tungsten carbide or the coated tungsten carbide, and also the diamond coated carbide. All right, and we can using the 4 different cooling method: dry machining, easy base cutting fluid, and the hybrid and nano fluid cutting fluid in here. And all you can see machining process, we can using the feed rate cutting fluid, depth of cut, and the MQL flow rate. All right, so next slide. So this is our final validation. How can reduce the carbon emission? We can check the energy consumption for the recycling system and the machine on, and also the material. And second item, we can check the cost element, cost analysis, and third one is machinability analysis. So 3 different elements in here. Next. After come out using all these things, we can come out the sustainability development model using the fuzzy logic technique, and we can check in here sustainability index in increase 90% compared to the conventional method. Next slide. All right, so this is my final slide in here. Using the 3 different methods, all 3 are the sustainable development, sustainable model. One is the dry, another MKL with the conventional cutting fluid, and finally is the nano fluid in terms of the nano MKL. We can see in here, so nano MKL is performed better compared to the others. We can see the green line is the nano. This is a lot of the parameter in here. All right. So this is my final slide. So we can see they have the 5 E's. We can consider the 5 finger in here. How many finger in here? 5. Okay. 5 finger. At the 2 pillar, 2 S. One is the society, another is sustainability. Consider the 2 hand. Now, I can, this 5 finger, I only move 1 finger. And we can touch the another one. Okay? Do together. This is the 1 hand. We can toss in here. We can toss in here. Any sound? No sound. We can make the 2.
Yeah.
If they have the sound, make the 3. If the sound is increased, make the 4. So that means when 2 pillar with the 5 fingers move together, they make a sense. So becomes a greener future. Thank you.